When doing a set of actions that repeatedly fail to achieve a certain goal, animals in general often give up and become passive, which can be strategic for preserving energy or for regrouping between attempts. That is, when you try to do something expecting something and this other something doesn't appear, you just become depressed and sometimes give up on trying that one specific thing, or just take some pause to try it again. But even though we can perceive this outside, we have little knowledge of what is happening in our brains or in the brains of others when those things happen. How can the brain identify behavioral and outcome failures and mediate those reactions? And more, how can we actually use this knowledge to help us to achieve certain goals, like not giving up, becoming more motivated, or creating more resilience even? Well, this is what a study on larval zebrafish tried to uncover. When certain brain activations of those animals are and can be very similar to humans, they become very good representations of what is happening or can be happening inside our human brains as well, or at least give us some biological clues. With these, the scientists tested both the motor functions and the whole brain calcium noradrenergic neuron activity of them. To simplify, they just tested the movement of those fish and tried to see what is happening in their brain. Noradrenaline is normally related to arousal, attention, cognitive functions, and stress reactions. It is a neurotransmitter related specifically to actions and to behaviors, therefore. So they are trying to know more about the motor motivations of the fish, more than the cognitive processes of them. After all, it is easier to give a questionnaire to humans rather for a fish, once the paper will not be wet and the ink will not suffocate the human to death. But anyway, the authors start by saying how even though perseverance can lead to success, some challenges are best met by high activity bursts, separated by behavioral calmness and inactivity. This pattern is often seen in many motile animals that find themselves unable to move before doing something spectacular or a brusque action, and vice versa. So very brute and very wary actions are always in interpolation with each other when it comes to very intense and specific behaviors or complex behaviors. For example, after being captured, a zebra or another prey can become very passive while waiting for a predator to loosen its grip before trying hard to escape. The same happens to those predators like lions or even cats. They stay still for many minutes before making an attack. Or fish in the mud that may attempt very vigorous movements and then contrast them by becoming very still in order to conserve energy so it can free itself when the opportunity comes. But how does the brain determine when it is a good moment to attack or to stay still, to move and give all you have, and the moments that you just see no effort that should be invested and therefore you should just sit back and relax? The neuroscientists then try to see the connections between the noradrenergic circuitry once it is related to motor functions and situations in which a person or the fish of the experiment would just see their efforts as in vain. And what they discovered was very interesting, because first they put the fish on a tank and then put two walls that it could see. Then the fish started swimming. And when this happened, the images on the sideways started moving as well. So it would think that their movements were actually making the fish really change its location. Poor fish, right? But it gets even worse. Because in another group of fish, they actually stopped the images or even put it in reverse. So even if the fish was giving all it had, the images would or stay still, or even go against their movements. So in a group, they were seeing the evolution in relation to their efforts. And in the second one, it was the reverse. Now, what happened? Well, the fish that didn't saw any evolution, they gave up on swimming. That's it. They said, fuck it, I'm going nowhere, then why should I keep moving? But they've done this only for a while, because some minutes later they were there again, trying it again to move. And if the image was still kept still, it would give up again. But if the image was actually moved, then the fish would start swimming even faster than before. How crazy, right? So imagine a hypothetical situation to delve more on this idea. Like a person using a treadmill. If the treadmill's display malfunction and shows no progress despite the person's effort, this person might become discouraged and slow down or stop altogether. However, if the display starts working again and shows their progress, they are likely to resume running and might even increase their speed, motivated by the visual feedback. But before the returning of the images, the experimenters investigated the brain-wide neuronal region of the fish and discovered a very huge amount of astrocyte activity during the passivity of the fish. Astrocytes are peripheral cells that surround neurons. In the experiments, they were mostly surrounding the noradrenergic circuitry of the brain. Therefore, the fish's brain were accumulating noradrenaline, and when these noradrenaline levels were too high, the animal just gave up. Well, what does this mean? That if you're having too much effort on something and you never see a reward, what happens? You just give up. Although it can be very obvious, it is also very interesting to think more about it. Because once the brain is trying to see how much worth or futile a behavior is, when is it that we have a behavior worth striving for? When should we give up? When should we keep going? When should we take a pause to start again? And when should we try something else? Well, if you think about the biology of it, you can say that your brain and your body actually tell you this by your physiology. If you're doing something and your body is saying, I don't want to go anymore, maybe, just maybe, this is a very good sign for you to stop doing that thing, or even if just for a while. And if we use some other research on other neurotransmitters such as dopamine, we can actually gain a very good complement to this. Because if not seeing a reward can be detrimental and punitive for your brain, then what happens after you get a reward you wanted? Or at least some few rewards in the path of getting those higher things that you want. Once dopamine is activated, it can actually reduce the levels of noradrenaline. Some medications for alcoholism, such as disulfiram, do exactly this. Because if you're trying to give up on alcohol or anything sort of vice you have, any punishment you receive can reduce your motivation to zero. The synapses of your brain are very fragile. That is, your noradrenaline goes to the maximum level due to the very high efforts you are taking. But when dopamine, that is related to reward or the perception of a possible reward, is activated, then you get happy. You reduce your noradrenaline and reinforce those neuronal paths that you were using in your efforts. If you were running and your body is telling you, I don't want to go anymore, this may be a good sign for you to stop, even if for just a while. But if you do something that reinforces this last behavior of running, such as drinking water, or even better, looking at your progress, then you reinforce or validate this behavior of running and can therefore be even more motivated to get running again, either in another day or in the next minutes after you're done relaxing for a bit. If you're studying and your brain is telling you, I don't want to study anymore, this may be a good sign for you to stop, even if it's for just a while. But if you do something that reinforces the studying that you have done up until now, such as getting a snack, or even better, reviewing what you have just learned, then you reinforce this behavior of studying and can therefore be even more motivated to get studying again. Although this is more hypothetical, you definitely can see it working in your life or in some set of behaviors you are doing, like cleaning things obsessively perhaps. For my personal experience, a very good example is definitely in video games, especially when I used to play games like Overwatch with some friends, in which the scores are always appearing and getting bigger and bigger after the match starts. You are always setting goals, whether to kill your enemies or just win, that is, noradrenaline starts rising, and then you get rewards for accomplishing those things. So dopamine rises and reduces noradrenergic accumulation, making you more motivated to go. So the desire to win or to kill my enemies, for example, which is effortful, and when I actually do this, it reinforces the behaviors of playing and repeating the process all over again. It's tension and relaxation, effort and reward, a dance of life. It is exactly what horror movies, TV shows, good stories, or even some people do to us, to our brain specifically. They create those very high expectations, those mental effort in us, and they give us rewards for that. That's why when you don't get something you like from a YouTube video, it can be detrimental and punish your brain, let's say, and you'll never go to that YouTube channel again. But if you get something new, something good, or something useful even, it can actually make you not only want to see more of these videos of this channel, and give it a like, share with your friends or with other people as well, but also to subscribe to the channel and wait for the next ones. So to summarize, effort is good, but too much effort can make you give up. Therefore, if you give a reward related to the process, you become more motivated. And the good thing is that this reward doesn't have to be something complicated. It can be something simpler, such as just looking at all the efforts you have taken or done up until now, all the evolution you have made. If it is running, check the kilometers you've run. If it is weightlifting, check how much weight you've lifted or for how long you've done the exercises. If it is studying, check the notes you're taking and all the pages you've already wrote or read, and so on. Doing this can maybe help you avoid working and taking so much effort to just give up from a burnout later. So be alert. As I've talked about on another video of 3 tips for improving resistance in long-term decision-making, these rewards could also be the imagination of yourself in the long run. If you want to know more about this, you can check that video here. For now, if you're interested in some therapeutic and analytical help with this, you can check the link in the description and book a consultation session with me. For now, all I can also say for you is to just relax a bit and reward the process, or realize all the achievements and efforts you've done up until now, and see you next time. Goodbye.